Hi, welcome everyone. We are going to go through the proportionality theorem notes together. You can either just follow along with me or you can print out the notes and complete them along with me. Either way, it's up to you. The first one we're going to talk about is the triangle proportionality theorem. So it states, if a line parallel to one side of a triangle intersects the other two sides. Okay, so if these are parallel, and these are both intersecting the sides of the triangle, then it is dividing the sides proportionally. So this is kind of key. So it's saying whatever proportion this side is broken into, that this side is also going to be broken up into the same ratio. So like if this is 1 to 5, then this side is going to be 1 to 5 as well. So the way you would set that proportion up is you would say, okay, well, if this side is proportional to this one, the pieces along this side are AC and CE. So those are the pieces along that side there. And then you would say, okay, well, whatever this ratio is, because remember, proportionality means they have the same ratio. So whatever this ratio is, it is equal. I'm going to make a proportion. Now, I did the smaller piece to the bigger piece. So when I create my other ratio over here, I have to do the smaller piece, which is BD, over the larger piece. So that is kind of the example for how you would set up the proportion for these proportional sides. So if we came over to the examples, again, there's ratios can be written in a bunch of different ways. The thing you always can check to make sure you did it correctly is the cross product. And I'll show you what I mean by that again, because we haven't kind of used that vocabulary in a while. So if I set up, and again, it doesn't matter where you start. So I'm just going to start here with X. So X and 33, they're along the same side. Whatever this ratio is, it's going to be equal to the ratio over here. Now look, since I started with this bottom, which is smaller, I'm going to have to also then start with the 18. So you kind of, again, you have to build your ratios the same, small to big. So then I'm going to go small to big. So again, remember, this first step can look different. Okay, now cross product is the step after the proportion when you cross multiply. So when we cross multiply here, 27x is equal to, and then we have to cross multiply here. That is just 18 times 33, and I'm just using my phone calculator right now, so that is 594. Now this is a cross product, all right? So again, your first proportion might look different, but if you set it up correctly, then everybody's going to have the same cross product, okay? So that's kind of what you want to check if you do not have the right answer. So now if I divide 594 divided by 27, then we're going to get 22. Remember, another way you can check yourself is we said that these should be proportional. So if I plug in 22 right here, 22 divided by 33 should give me the same exact decimal as 18 divided by 27. Okay, if they don't, then obviously you did something wrong. All right, on the second one. Here again, you got to be careful. Okay, you notice that 20, they gave you the whole entire side. Okay, so we have to go, okay, well, if 20 is the whole entire side, so 20 is the whole thing over this larger section. We have to set up this ratio the same. So we go, oh, well, what is this whole thing? So this now gives us 16 if we do 4 plus 12. So we get that's the whole thing, and then the larger piece is 12. Again, there are different ways to set up this proportion. You always just want to check your cross product there when you are checking maybe to see why you got the wrong answer. So 20 times 12, that is 4,800, and then we're going to divide that by 16, and Sorry, that's not reasonable. Let me redo that. I had too many things going on in my phone calculator. And so 20 times 12 is going to give me 240, and then I'm going to divide that by 16, and okay, thank you, that is much more reasonable. I knew that 300 didn't make any sense in the whole wide world. All right, so that is the proportionality theorem with parallel lines. Okay, also in number 2, you have 3 parallel lines, and they're being intersected by 2 transversals. So it divides the transversals proportionally. So remember, these are our transversals here. So the pieces along the transversal, they are going to be proportional to one another. So AB is on, again, there's different ways you can set this up. Now I can go AB to BC as my first ratio, or I can actually go AB to DE as my first ratio. So remember, there are different options. AB over BC, if I stay along that transversal one, then that's going to be proportional to DE over EF. All right, so we can come over here, and again, you can set up your first ratio going left to right, right to left. Maybe we'll do a different way over here just so you can see. So if I go x over 12.5, that's going to be equal to 12 over 15. Because if I go from left to right, I've got to go left to right. Again, this could look different. So you always want to check your cross products. So 15x is equal to 12 times 12.5, that gives me 150. X is 10. Is that reasonable? Yes. All right. So now I could do this one. Right? You could also go this way and set up, and you can go, okay, 27 over x plus 10 is going to be equal to 18 over x. So we have to be careful here. We have to do a little bit more distributing right here, okay? And so that's going to give me 18x plus 180. So don't forget to distribute that 18 to both parts. All right, now we're going to have to take the 18x to the other side. And that is 180 is equal to, what is that, 9x? So x is 20. Okay. All right, next, the angle bisector theorem. So if a ray bisects an angle, so this angle is being bisected by this ray BD, then it's dividing the opposite side, which is AC, into 2 segments whose lengths are proportional to the lengths of the other 2 sides. I know that's like, what in God's green earth did you just say? All right, so it's saying that AD, this is the opposite side that it is dividing, and this is the length of the other side, okay? So it's saying that AD over AB, so right, this opposite side and the adjacent side is going to be proportional to the opposite side and the adjacent side. All right, so let's set that up over here. Again, setup is could be different. I'm going to go from adjacent side to opposite side. So then since I went from the adjacent to the opposite, I also have to do the same thing here and go adjacent to opposite. So this is the adjacent side to the opposite side. Let's cross multiply. So that's 10x. And then what do we have? 12.5 times 8 gives me 100. So x is 10. And again, remember, you can check because proportional means they have the same ratio. So if I took this 10 and I plugged it in there and I do 10 divided by 8, 10 divided by 8 is 1.25. Okay, well, this should equal the same thing. If I do 12.5 divided by 10, what am I going to get? Okay, so now that's how I know that this 10 is the correct answer, because both of these ratios are the same. All right, so over here, this one's pretty, similar. We can also set this one up a different way just so you can see. I can go adjacent over adjacent, so I can go here to here, but I did like the smaller piece to the bigger piece, so then I can go opposite over opposite. Again, the proportion might look different. Your cross product should be identical to mine when you do the cross product. So that is 20x. So basically, right, it's 10 and 20 is half. So if we're doing 150 divided by 20, all right, we should get 7.5 because yes, 7.5 is half of 15. Hope you enjoyed that distance learning. If y'all have any questions, again, remember, join the conference on Canvas from 8 to 8:30 every morning. And yes, it's meant so that I can see your beautiful, shining, smiling faces. Or send me a remind if you're not up that early at 8 a.m. All righty, take care.